All right, folks. How we going this wonderful, wonderful morning? Let's break that right on down. How are y'all? Very, very good to see all of you. Welcome, welcome, welcome. We are going to be doing some very fun stuff this morning. My name is John. Behind me, we have the wonderful Blavingard, and we are going to be building ourselves a fun little starter project in iOS SceneKit. This is a really, honestly, a framework that I like a lot. It's designed really to make a lot of the structural stuff around doing both 2D and 3D games really easy on both iOS and Mac. So that's something that we're going to be looking at pretty heavily today. So as a starting point on that, we are going to set ourselves up an app. We are going to, let's focus, I think, on iOS today. You can multi-platform this. So if we want to, in a bit, we might show you how you can run it as an iPad app on Mac. But for the moment, we are going to keep this as it is. And we are going to need a name for this. And I mean, before that, we're going to need ourselves a game concept. So I would like, please, some pitches in Twitch chat for what we're going to touch on today in terms of games. Could be anything you want. Really gonna push ourselves out of the comfort zone today. My immediate thought process was some kind of Fruit Ninja style thing, but I'm very up for any other potential suggestions here, as long as they're not horrifically complicated. No core data in this instance, because sweet God, I am not a fan of core data. Anyone who's ever done iOS stuff will tell you that core data is an experience. Very much one. Okay. All right, I think we're gonna kick this off. We're gonna go with the Fruit Ninja clone concept, but we're going to let's switch it up a bit. We're going to build ourselves IKEA Ninja because why not? All right, put that in that folder. I have misspelled it. Phenomenal. Okay, please hold, because I need to go and delete that for reasons of I do not want the misspelled project. There we go. Okay. Let's get ourselves that sorted back out. App iOS. Pop that in there. Phenomenal. Okay, and let's then stop that screen and bring. There we go. All right. Okay, welcome back to Xcode. Okay, supposed to stream is only for people of iOS devices. If you have a Mac, you can run this on the iOS simulator, but this is specifically for folks who have either iOS devices or Macs. Yeah. Okay. So let's wait for this to load on in, and then we're going to start doing a little bit of work on it. We'll see if we can't do some fancy Swift UI stuff at some point in this, which should be good. In fact, actually, we're gonna reboot this project slightly just on account. Okay, application. Yeah, I think we're gonna go down this road, which is fine. Okay, one more screen set for the road. Okay, so we put up. Do I need to download the Xcode for this? If you want to follow along, yes, you will need Xcode. Though, given how chunky Xcode is, you might want to download it now and then follow along from the next stream, because it could take you a hot minute to get it installed. Okay, template, iOS, game, wonderful, IKEA, Ninja. Language, going to go with Swift, because good language. Game technologies. Okay, there's a bunch of stuff here. Metal is literally what it says on the tin. This is Apple's, like, bare bones, write all of your own graphics framework, which is phenomenal if you want to do that kind of stuff. I am not an OpenGL person or a GL person generally, so I am going to be leaving that safely alone. We have SpriteKit, which is kind of like SceneKit, but more simplified. It's designed specifically just for 2D games, whereas SceneKit is designed specifically for both 2D and 3D games. So you get that, and also a bunch of extra complexity in your options. Like there's framework stuff around being able to automatically handle collisions, gravity, all that kind of fun stuff. And then Reality Kit, which is specifically designed for AR games, which we are not going to be touching on today, but maybe touching on a little later in the week. We'll see. Okay. So we are now set up. Let's take a look. Set our display name, which is great. Okay, we are going to turn off landscape orientation. We are going to allow portrait, and let's do portrait for now. So that's all sorted. We don't need to touch any of the other parts of this. Okay, so let's walk through what we've got created so far. So we have a good old UI. Okay, so we are in UI kit. So for anyone who is familiar with Swift UI at this point, oh, hang on, we've lost the screen. That's phenomenal. We're back. There we go. Okay, so since SceneKit is a primarily UI kit based framework rather than building on top of SwiftUI or any of the more recent frameworks, instead of fun SwiftUI setup stuff, we get ourselves a good old-fashioned app delegate. So set up here, did finish launching with options. So if we want to run any stuff when it kicks off here at the point the application launches, we can do it there. We'll assign active, basically means, like, yes, it says here, was the user method to pause ongoing task game. Should use this method to pause the games. This basically means that it's been, like, temporarily paused. Or like if you picked up a phone call, then this function will trigger. Did enter background. This means that it has been sent to the background and will eventually come back again. So it's sort of like a sleep mode rather than a kill. Enter foreground, opposite of that. Application did become active. That is always fun. This basically is like if you've killed any tasks that were running when it went into an active mode. So like when you hit resign active, and you like stopped anything there, you can restart it here. You should also usually refresh your user interface to some degree. Okay, so let's take a look inside our art box here. So we have a couple of things here. Prefer compressed textures. So this just means that inside our asset catalog, we're going to use the compressed versions. Always use the Y up axis, which is fine by me. It just means that Y is always going to be the vertical axis rather than not. And look, we have a tiny little 3D ship, little F-16 looking thing here, which is cute as hell. And as part of that, if we head on over to the texture, we can see that this is a little 512 by 512 texture, which is mapped on top of this ship. And the way that it does that is that if we click on over here, we can see all of our transforms, and then we can also see the attribute here for the actual mesh shape itself. And then if we head on over here, we can see all of our geometry. If we go to Materials Inspector, we can see that we've got our texture selected here. So if I just change to this to say like black, it would just have that mapped on top of it. Otherwise, we can add the texture back. There's some stuff here around like metalness. So this is what's giving it that. So if I bring that completely down to like dielectric, you can see it's very flat. If we bring it all the way up to 1, we can see we get that sort of like sheen to it. That nice kind of effect that we've got there. Transparency, occlusion, displacement. We'll talk about those at some point, but for now, don't worry too much about them. Settings down here, this is mainly to do with if we have transparency layers. Over here to physics body, this is interesting. So this allows us to actually set up physics for each one of our objects, which will then affect the physics system within SceneKit itself. So we've got a few different options here. Static, which means that it will effectively just act as a static physics object. Dynamic, which means that it will have some form of mass and therefore like kinematics associated with that. And then also kinematic, which is basically kinematic, as in basically missing out a good chunk of the of that side of it. Okay. Can't see options. Sorry. Can you clarify what you mean by can't see options? I can see them down the right-hand side of the stream for me. So if you can just double check that, that would be awesome. Oh, right, I see. Yeah, yeah, that's I will talk them through as I go then, but unfortunately that seems to be a limitation of the screen share, which is a little annoying. Okay, background here, procedural sky is what it's currently set to, so no complaints there. And then we have our environment fog, which is always interesting. Maybe if I add a little. Okay, that is a lot of fog. Then we have just reflection, standard physics stuff, texture embedding, all that jazz. Great. So this is a .cn file. We can then pick this up and out. And if we head on over, let's take a look at our game view controller. So this is already getting into some fun stuff. So step 1 up here, we create ourselves a new scene. We name that scene, and specifically we are well, when it says named, what it actually means is that it's pulling out this specific resource. So we're pulling out a little ship here. Create and add a camera to the scene. So we create a node for that. We create a camera, attach that camera to the node, and then we add our child camera node to the root node of the scene itself. Set that camera's position. Create and add an omni-light, which basically just means that it's gonna light everywhere. So we don't end up with like specific shadow attributes. It's like point lights effectively. And then we create ourselves just some ambient. So we have effectively like a light going in all directions in the center, and then we just have some ambient light so that we're actually going to have some light in the scene itself. Grab the ship node. So we pull that out and run a little animation. Assisting action rotate by. So we're rotating this on the y-axis over about a second. Pull the view back. Set the scene to the view. Allow camera control. And then also enable our debug statistics. Finally, set a background view. And then we're going to add a gesture recognizer. So down here, a couple of things here. So on the supported device orientations, we are specifically checking if it is a phone, we allow all orientations except for upside down. If it's anything other than a phone, we just allow all of them, which is interesting. Preferred status bar hidden. The override here specifically hides the status bar. So that means that we have that non-visible for the purposes of our scene. And then over here, handle tap. So this is the gesture recognizer that we set up here with the selector. So what we're going to do here is grab the view and typecast it. And then we're going to use the gesture recognizer and call .location in the UI view itself for scene view. So we are effectively figuring out where in the view itself the actual tap has been made. And then what we do is we call scene view, and we run what's called a hit test, which means that we effectively look, and the options here is basically like the options that we have are anything from like backbase culling, just stuff with bounding boxes, ignore hidden nodes, for example, ignore child nodes, only grab the first thing we found. For our purposes, we don't care about any of that. We just want everything. But effectively what we're doing is we're taking the point that we've gotten from here, so the point in the view itself specifically relative to the view, we pass it into hit test, and this will then return us any objects that we have tapped on. So if we have in fact tapped on at least one thing, we are going to retrieve that thing. We are then going to go off and get the material for that thing. And we're going to do a little animation on it. So we're going to start a scene transition. So this effectively allows us to create, how do I put it? It effectively lets you create a little block in which you then basically begin, make a bunch of changes, and then commit, and then that will then apply itself on top of the existing scene graph. So we say our animation duration is going to be this. We set our color to red, and then we say once this is done, set it back to black, set the animation duration back to black there. So what this should do is give us a little bit of a poof of color. So now that we've run through all of the detail of that, let's get this running. So I'm going to kick the iOS simulator off. And let's see if we can bring that up on the screen, which I think we can. Wonderful. And we're going to wait a second here for this to load up. And what we should get, with a little bit of luck, there we go. So we can see our debug info at the bottom. We're running at a very wonderful and clean 60 FPS. We have about 2,800 polygons on the screen. 3 objects because we know it's 3 objects because we've got our 2 light sources, which both count as objects for this purposes, plus the 1 object of the aircraft itself. Then we see here that if we click it, it goes red for a second before going back to normal, and if we click anywhere outside of the object, then it doesn't. In fact, you can even catch it if you click the tail as it goes around. You see where that lines up. So there we go. So we know that it is definitely doing the collision on this correctly. All right, cool. So we've sort of run through the general basics of how SceneKit works on a conceptual level, but what are we going to do beyond that? So let's take a quick look here. So let's take a look in our game view controller as a starting point. So I'm going to clean some stuff up here just because we are going to be building out something a little bit different. So we're not going to need a good chunk of this. So our view did load up there. We're going to reverse those bar here, and that's fine. This I'm actually going to change to something slightly different. We're going to do an override should auto rotate, which is going to mean that it just automatically does that for us, which is great. And then the other thing we need to do here is call our super for good practice. Okay, so let's set up our scene view. Okay, and then what we're going to do here is set ourselves up a new setup view, and we are going to say scene view equals self.view as scene view, just like we did earlier. Clean that up a little bit. So what we're doing here is we're casting self.view to a scene view, and we're then storing it in that property. Basically, because before we were having to like recast it every single time, and that's just not. There we go. And that's just not like, it's both unpleasant and it's also not particularly good practice. So the other thing to note here as well is that if we're working cross-platform, scene view is an NSView subclass in macOS or UI view subclass on iOS. So this effectively means that like regardless of whether we're working on Mac or iOS in terms of running it, scene view is always going to be the same type. So that's fine, which is great. Treating it as an optional will never produce nil, which is fine because we know it's always going to be that. So we bracket it in order for that to work correctly, which is wonderful. And then let's then do the on setup view. We're going to set up scene, and we're going to do is our scene. We're going to set that up from there, and then just after here we're going to do set up view and then set up scene. So we've got a wonderful little bit of lineup there. Cannot find a scene in scope. That is a fair point because I've not defined it. There we go. Phenomenal. All right, so step 2 from here. So we have our last asset catalog, which we are going to just take these 2 out of, which is fine. So that's all good. So usually, in fact, actually what I'm going to do here is I'm going to trash this and make a new one just so I can show you this process. But what we should get here is new file. And then if we go all the way down to asset catalog, or more specifically SceneKit catalog, which is what we're after here. So this is designed specifically for managing fun SceneKit stuff. So what we will find in here, if we just make that. So there's usually the way that this works. Oh, that's fun. We've just had an Xcode crash. Okay, let's wait a second for this to open recent. Xcode quit unexpectedly. Exciting. Okay, that's stable now. So let's bring that back. Wonderful. Okay. So asset catalogs basically contain 2 separate things. You have sounds and textures. Those are kind of the 2 main things that you're going to end up with. So that's kind of like the core here. So let's take a look here at cameras, because that is probably going to be the next thing that we want. Okay, var so camera node up, and then down here we're going to do a setup camera. Gonna make a new SCN node. This then needs to be an SCN node. And then camera node dot camera equals SCN hit camera, which is great. And then a camera node. Why do I keep spelling camera wrong today? Position. And we are going to do SCN vector 3. And then this gives 3 different values. So we're going to do 0, 0, 10. So we're slightly elevated, and then SCN scene dot root node dot add child node camera node. Lovely. And then we just drop this one in just below setup scene, because we are going to need the scene visible before we can do that. Okay, so let's start doing some fun stuff with Swift. So we are going to make ourselves a new Swift file, and we're going to define it as shape type, which is wonderful. And we're going to do a little bit of enum structuring. So we're going to have a few different ones here. So box, sphere, pyramid, plus, and you'll see that it's auto filling them here because they are also SceneKit types. Fuel cylinder. Cone. And last but certainly not least, cube. Phenomenal. So now we will just add a function to randomize this. So the last one in the list, which is going to be the cube. We're going to do arc4 random uniform. And the upper bound becomes value plus 1. We're going to return type. Know that that's always going to be a success because we've bounded it, and then this is going to be shape type is what we are returning off the back of it. All right, phenomenal. So let's get some geometry in our game. So if we make ourselves a spawn shape function, and we're going to set some geometry up, and we're going to do call our random function, set ourselves a default, which is going to be these are floats. Chamfer radius, no chamfer. So that's fine. which basically means that in the event of, we might have to change some of this later in terms of like how the geometry actually operates in practice for bounding boxes and stuff, but for the purposes of now, we're just going to leave that as it is. And then we're going to make ourselves a new node. Our geometry is going to come from our geometry type. And then we are going to root node, add child, geometry node. Okay. So we're going to set that as blue, and then we're going to spawn a shape in. And what this should do at this point, if I pull up the iOS simulator, where's the screen? There we go, we got it. Perfect. So what we now have is our wonderful blue background, and we have the shape there. So let me just, I'm just going to bring Xcode back briefly, and we're just going to talk through where we've gotten up to so far. So we have, in order, we set up our view. So we define a new SceneKit view. Well, more specifically, we take the existing view that we know is already there, and we cast it to a SceneKit view, because we know that I'm going to move that in there. We know that in our, as you can see over here, in our actual interface view controller scene, this is already defined as a SceneKit view. So we're not exactly getting away from that one. At least on the storyboard, so that's easy. Define that, set it up with a background color, which for the moment we've just picked blue. We then head on over and set up our scene. So we define a new SceneKit scene. We then set the scene on the SceneKit view. So those are then attached to each other, because you can have a single SceneKit view but multiple scenes, for example, so you can be swapping between them. We then set our camera up, so we create a new node, which is how SceneKit handles attaching most stuff. So if I do, for example, scene.node.add, you can see that you can add child node, audio player, particle systems, animations, animation players, all of that. But the main thing with most of this is that you're going to be creating nodes, and they may be visible nodes, they may be invisible nodes. Yeah, nodes are the way of the world. So we create that on the camera. We then set the position with a vector, so XYZ coordinates, and then we add that to the root node of our scene. And then finally, which we've just worked on, we've created the shape type enum. So we have a type for each one of our shapes at the moment, which are, each one of these is a potential SceneKit shape. We set up a little function to pull a random shape from this list. So we have the max value, which is the top one here, in this case tube, and then we are calling arc for random uniform to basically just get a random value within those bounds, and then we are casting it back to a shape type. Over here in our spawn shape function, we set up a holder for our geometry. We do a switch statement here. For the moment, we are just defaulting all of them to returning us boxes. And then we are creating a new node with that geometry and adding it to the scene. Does it still render through metal? Yeah, almost all SceneKit stuff under the hood is metal. In fact, you can see down here in the debug logs a couple of messages about various metal-related things. Okay. let's keep on moving forward. So I'm going to do a couple of things here in setup view just to make my life easier. So we are going to add shows statistics, allows camera control, auto enables default lighting. So what that should do, yep, that is correct. Okay, so show statistics, that brings back that little statistics panel that we saw a little earlier. Allows camera control. This just lets you use gesture-based active camera control. So basically just sets up the ability for you to like use like the usual stuff, like single finger swipe, two finger swipe, double tap, all of that. Auto enable default lighting is a really good one for when you're just starting to debug stuff, or just starting to build out the project and you don't want to go throwing light sources everywhere. What this does, this basically gives you omnidirectional lighting. So you'd have to worry at this point about adding, we're not going to worry right now about adding our own light sources. We're just going to illuminate the whole thing and then see where we go from there. Is basically the way of it. So let's push that up onto the simulator and swap our windows over. Where we headed? There we go. Phenomenal. So we can see here that because nothing is moving, we are currently at 0 FPS. We have two objects in here because we have our camera node and we have our box. Despite all of that, our box still takes up 26 polygons, which is interesting. Also, if something I didn't mention a little earlier, actually, which is probably worth knowing, especially when we start getting into the more complicated stuff, for the statistics, if you click down here, you see this little plus icon. This actually gives us the full breakdown. So all of the stuff that we have potentially available to us. And what that gives us, effectively, is the ability to actually look at the explicit breakdown of all of the individual elements that makes up our scene render. So we can see here how much time is being spent on GPU rendering, how much time is being spent on animations, how much time is being spent on physics, how much time we're spending on the particle system, and then also then look at the breakdown overall of like, okay, how is this actually then affecting performance in a tangible way, which is really helpful. Okay, let's keep moving on forward. So we are going. Where's my notes? There's my notes. Okay. So let's briefly. We're going to pop back into Xcode again. And let's briefly talk about. A little earlier, we were talking about physics body types, right? So there's a few key things when it comes to dealing with physics bodies in SceneKit. You have three fundamental types, as we mentioned earlier: static, dynamic, kinematic. So the practical way to describe them, because we were sort of talking in a sort of abstract terms about them earlier. Static is exactly what you think it is. It doesn't move. They have collision physics, so they will stop stuff that end up hitting them, but they inherently will not move on their own. So you can think of these as like walls or like cars or like immobile boulders, like stuff that you're expecting to not necessarily move in response to things, but you're just expecting to sort of exist and be collided into, that is. Then you have dynamic bodies, which are, again, pretty simple. They are automatically moved by the physics engine in response to like a collision. So, as an example, like a chair, if you push a chair and then the chair moves, that's a dynamic object. And then also, like if you had, for example, a cup on a table and you shot the cup and the cup falls off the table, that is a dynamic body. And then we have the fun stuff, which is kinematic bodies. So these are they're not automatically moved. So the difference between dynamic and kinematic, a kinematic body still has all of the same stuff, but the difference between that and a static body is that a static body you can't move at all. A kinematic body you can move, but you can only move it programmatically. So if you have a kinematic body, if it collides with a dynamic body, the dynamic body will move, but the kinematic body won't. So it's the idea of like things that you want to move, but that you specifically want to control manually. So like doors or elevators or cars, as I mentioned earlier, a car would probably usually be a kinematic body rather than a static one, unless it was parked. Even then, probably still kinematic. So that's our three fundamentals there. And so let's jump in and build ourselves some physics. So we're going to head on over into our wonderful spawn shape, and we are going to add, actually no, we're going to add it down here. Geometry node dot physics body. So we're going to set a physics body on this. We want type and shape because we want dynamic, and the shape we are just not going to set to anything for now. So this is now what we're doing here. So we're creating a new instance of SEN physics body, and we're then assigning that to our geometry node. So what that then means in practice is that we can do our own physics calculations if we wanted to, but SceneKit does it for us. So effectively what we're doing is just setting up so we have two separate objects. Effectively, we have the object that we actually see, and we have the object that the physics engine calculates from. So SceneKit does physics calculations usually a lot more frequently. At least most game engines tend to do physics and like other calculations more frequently than render calculations. So the idea of having almost like a second world or a separate set of objects just to do physics calculations on means that it can work on those without having to render all of the big, complicated, high poly count graphics versions of the same objects. It uses like a skinned down version, basically. And the fact that we're specifying nil here on the shape itself, what that basically means is that so if you pass in nil for a physics shape, SceneKit will automatically generate that shape based on its physical geometry. So it'll effectively take the existing geometry of the object and simplify it, which is great. Sometimes, especially with like, if you, as an example, if you have like an FPS, then you will probably want to add more shape, and therefore you can create an SCN physics shape, which is an example where you can effectively, basically build all of that out from there, and then add your transforms on top, and then effectively what you'd end up with is a more specific geometry, we'll say, but practically that doesn't much matter. So let's build and run that. Let me add the phone. There we go. So let's run it. Sweet. So we see exactly what we were expecting, which is that our box immediately falls out of bounds because there is no collision around the edges, and therefore it's just going to go. The other thing that we should also be able to do here, which is slightly fun, is going to be actually, yeah, there we go. Because it's a 3D object, we can actually follow it all the way down, which is kind of fun. A little bit trippy, but yeah, okay, sweet. So, congratulations, we have invented gravity, just like Isaac Newton wanted. It's also worth noting here, because I didn't mention it earlier, SceneKit scenes have gravity turned on by default. So if you want a scene that specifically doesn't have gravity, you're going to have to like explicitly disable that before you do any of the fun stuff. So let's try applying some forces to this. So just after we create the physics body, let's do some yeah, that'll do. And then random y float dot random 18. That's cool. So basically, what we're doing here is we're just setting up a couple of randomized. Hang on, that's 3 dots, isn't it? Not 2 for those purposes. There we go. Yeah, so we're creating 2 random values, the x value between -2 and +2, and the y value between 10 and 18, just as a ballpark. And we set ourselves up another SCN vector 3, which is always wonderful. X, random y, z, we'll just set to 0, because we don't want to be shuffling that anywhere for now. And then we're going to do geometry node dot physics body, which is a node at this point. So we'll unwrap it, apply force. Okay, so we're going to do force position. Oh, we forgot to define a position. That's probably going to be a problem. Position equals SCN vector 3. Yeah. I'll do. As impulse. True. So, we create 2 random floats. We use those to then create a vector for our force. We set a position slightly off center. So what this should do theoretically is actually spin it slightly off of center from there. And finally, we then apply that force to the physics body. And theoretically, what this should do with a little bit of luck. Let me pull the code up to just walk us through this briefly. I really wish StreamYard had the ability to show multiple screens. Here we are. Okay, so we create our random x and our random y. We set them up. So we create this force vector, which is the direction that we're going to be pushing in. We set this position, which is slightly offset from the center by 0.05, so that it will give us that spin. And then we specifically call apply force on the physics body with the force and the position that we want to apply that force in order to execute it. So let's head on over and we will... Phenomenal. Okay, so we're up here. Let's rerun this. Great, love that. exceptional. And then it just sort of like flies off like a bird somewhere over here. Don't know where it is. There it goes. Woo. Phenomenal. And we're still rendering at 60 FPS, which is my favorite. Cool. So we've successfully implemented some degree of physics, but forces aren't the only things that we can necessarily apply. So we also have the ability to apply torque, which is only going to affect spin, not momentum. So when you're applying a torque force, you are specifically specifying... Hang on, let's add one in here. So as an example here, we can do... physics body apply torque, and then that's going to be an SCN vector 4. So because the reason for that go 1, 2, 3, and then this is then going to be so these determine the rotation axis, and then the W determines the rotation angle, so the actual magnitude of the torque. So if we say 0.7, that's going to be pretty chunky. Put that in there. What we should then see when I run this is that wonderful extra little spin on there. So we can see now that it's almost tumbling with a very slight level of side spin, which is phenomenal. So let's go back over to the thing. There we go. Phenomenal. So this is what I was talking about. So torque here, we set up 4 values. So we have our positional values and then the actual impulse level of the torque. And then there we go. We just call apply torque in the same way that we would apply force, except we don't need to specify the position because the position is embedded in the vector. So that all works out pretty easily. Okay, so what we're going to do here, I think let's start by just tweaking our camera position a little. So if we go to like 0, 5, 10, just those for the purposes of visibility. And then also, let's make them random. Yep, okay. So let's see, spawn shape, where you create geometry, let's set this, so UI color. Let's actually set that up as we're going to need to create ourselves a okay, let's just create a couple of extensions to give us random color. So this is going to wrap import UIKit. This effectively just adds a little random function onto UI color, so it gives us 3 random CG floats and then a solid alpha, and then we just do some stuff here to basically calculate a random float within the parameters that we have given it. And now UI color should now have a member of random, which it now does. So what this should then do, with a little bit of luck, let's go and add our screen back. Okay, off we go. So if I now run this, what we should see, wonderful, completely different colored blocks being randomly thrown around. Love that for us. What a phenomenal moment. Okay. So let's move on from here, I think, and let's take a look. Oh, actually, we are on the hour, so I'm going to take a very brief couple-minute break to just grab some water and stretch quickly, and we will be right back to work next on the renderer loop and automatically spawning in our objects. We'll see you folks very shortly. Alright, folks, welcome back. We are going to be returning to our wonderful little project with some work on render loops. So let's get the code back up on screen. The good stuff. There we go. Wonderful, wonderful. Okay. So let's see how we're capable of pulling this off. Phenomenal. Okay, so let's get ourselves a SceneKit render delegate in here. So we have our game view controller class, so we're going to go right down to the bottom. I'm going to put an extension on this. Scene renderer delegate. Go. We're looking for renderer update at time, which is great. And then we're going to do shape. So this is going to give us a hook into the render loop, effectively. So this here allows us to start working within the actual confines of the game engine itself. So we get them down to the bottom of here, scene view dot delegate self. So that's then going to now going to call the delegate methods that we've now defined down here. And then let's see what that gives us. Add that back. Phenomenal. So we've got that there, and let's run this and see what happens. Yep, and immediately we are just filled with objects, just all of the objects. About 100 of them, give or take. This will not stop. I'm also actually slightly aware of the fact that my geometry is not actually doing what I want it to. So let's just fix our randomizer quickly. Cylinder. Radius and height. Pyramid. That's not a valid answer. Yeah. Porous. Cube. Phenomenal. Right. Default will never be executed. Well, you know what? That's fine by me. Okay, so for those unaware, this is the I love this. This is the giant switch statement that we now have. So we've set up all possible forms of shapes. And what this should mean is that when I bring this back up and we run it, there we go. We now get all kinds of weird and wonderful colored shapes. Phenomenal. Okay, let's stop that because that is absurd. Physics shape does not support a cone with a top radius that does not equal 0, 0. Fair enough. Okay. So, as we are quite aware, as we've just seen, this is kind of a lot. So, what we're going to want to do here, just below our camera node, where's that? There we go. We are going to set a timer. So we now have a time interval set. And what we're then going to do down in the renderer is we're going to say if time is larger than spawn time, and we spawn a shape, then we also set spawn time to a time plus a random interval. So we're going to do float.random, and we're going to do what, 0.2 to 0.5? Yeah, that should do it. What this should do, theoretically, is anywhere between 0.2 and 1.5 seconds, it should throw out a new shape. That is theoretically what we're trying to do here. And I've just realized that screen hasn't switched back again. Lovely. Here we go. So we have set up right at the top here, spawn time, time interval 0, default that to 0. And then we are checking if our time is larger than our spawn time. And if it is, then we spawn a shape and we set our spawn time to a new random point in the future. Somewhere to aspire to. Okay, so let's then see what this actually gives us as a result. So if we bring the simulator back up and we run it, what we should, there we go. So this is a bit more manageable. Admittedly, still kind of chaotic, but we get it, right? Like there's a level of this, but it is worth noting here that you can see that there's still quite a few objects that keep showing back up. And it is, to be fair, it is worth noting here. SceneKit now does do this to some degree. It's way better than it used to. But it used to be that if you added child nodes, they were never removed even after they went out of bounds. So I'm going to just show you for the purposes of just understanding how this concept works. We're going to do a little bit of object cleanup here. So we have spawn shape. We're going to define clean scene. What we're going to do is for node in scn scene.rootNode.child. We're going to go through all of the child nodes currently on the root node. And we're going to say if node dot presentation, because this is how it currently appears, and then position. So a few different positions here: world position, sim world position. Yeah, we don't need to worry about that for now. We want to check for the y. axis. And we are checking red is smaller than -2 because that will then not be visible to our camera. We're going to say node.remove from parent node. And then it will be magically cleaned up. So then what we do is we just drop this in our renderer, so we're automatically cleaning our scene out, and then is playing. I'm going to push that into endless play mode, which is great. So then if we then head back over, new question, can it be set for a screensaver? That is a very interesting question. I think maybe. So we can see now that our number of objects in the bottom corner is drastically decreasing, which is very good for us. This is now a much improved setup. Interesting. So from the looks of it, from what I'm seeing here, you can potentially do like you wouldn't be able to set it as an iOS screensaver, but you could potentially do it as a macOS screensaver. Which I think would end up being the way to go there. Like there's definitely ways to do that within SceneKit itself. In fact, I think a good chunk of the modern Ventura wallpapers on macOS are actually based off of SceneKit renders. Yes, found it. Hang on, I'm gonna drop a link. There you go. That is an example of SceneKit in use for screensavers. Oh, what have I done there? There we go. That's better. Right, let's get back to the code. Return ourselves. Phenomenal. Okay, let's see how we end up. So where we go from here? Ooh, I think let's do particles. That feels like a good way to go. Okay, let's make a new group. Particles. Create a new file. And we're going to go, where is it? Do you think it even have... SceneKit, does it even have particle system files? I was going to say, I think... It's going to be a SceneKit scene file, isn't it? Because they're not a thing anymore. Yeah. Okay, works. Actually, let's do it as particle template fire. Why not? Let's just do it old school. Phenomenal. Okay, so let's take a look at the editor for particle systems. Also, look at this. This is cool. I like this. So, SceneKit particle emitters. Kind of going into SceneKit here, but it's fine. We'll work with it. So we have a bunch of stuff here. Basically, texture emitters, lifetime, which is how long it is, position range, spread, scale, color blend, a whole bunch of stuff we're not going to really worry about for now. So let's take a look quickly at okay, so that's fine. Which is great. Trying to find my notes here for this. So, and that's fine. So what we're going to do then is that'll be interesting. It's machine set up programmatically. Okay, yeah, let's do this programmatically. Let's go old school. So we're gonna do func create trail color geometry return a particle system. So first we're going to set up our trail. And we're going to do a couple of things. Let's throw some, let's just throw some defaults in there for now and we'll work backwards. That's because I've not named it right. Going for geometry, and then we're going to return the particle system as a result. Which is fine. So let's actually set the rough values here. So birth rate we're going to set to 25. Warm-up duration. That's fine. Mission space, duration, direction, mode, spreading angle. Birth direction is going to be constant. Spreading angle needs to be 0. Particle angle then also needs to be 0. Emitter shape we were already dealing with, which is fine. And then it's just going to be Yeah, 1.45 should be fine. Actually, what I might do is set that to 0.2 just on account of... Yep, okay, more particle things. Lifespan, which is going to be 1, so it's only going to exist for a second. Linear velocity. Particle velocity. Zero mass 50, which is fine. One to run it at normal speed. Stretch factor 0 because we're not going to be stretching these. Which is fine. Is lighting enabled? No. Okay, which is fine. Physics attributes. Okay. Gravity, no. Affected by physics fields, no. Don't want those to impact. Die on collision, no, because we don't want them to disappear. If they interact with other nodes, okay, then the rest of that should be fine. Duration 1. Idle duration none. Yeah, and then it loops. Okay. So let's go. Now we have this giant thing. Let's go back up here and separate this out. Basically build this out from here. Geometry, and then we're gonna create the geometry node, and then we're gonna do geometry node dot add particle system trail emitter. Phenomenal. So let's see what this gives us now that we've pulled all of these wonderful pieces together. So here's how it was before. And if I reload it, we now have all of these wonderful little particles following each one of our objects. I'm slightly confused as to what's going on with the geometry with these. But I understand what it's trying to do. I just don't get why they're all cubes. But that's fine. For now. Point being is that we actually have working particles to some degree. Okay, so let's switch back to our code. And we are going to add a couple of extra things before we're done. because there's a few pieces to the puzzle here that we've not quite managed to hit. So let's head on over to here. Okay, so let's do some setup here. So I'm trying to think, how would we? So we're probably gonna want to go down the road of doing touch interactions again. We also need to name our nodes. So if we go to spawn shape, hang on. Because this is what's actually going to become the physics node. So if color. So this is going to allow us to check basically whether we have tapped on the right object or not. So the idea is that if we tap on a black one, black object, we know that that is a bad object, and therefore we can just check the name. And then if we tapped on an object that has a name of bad, then we can validate from there. So let's go down here. I'm going to set a function up for this. I'm going to score. Otherwise, we are going to decrease score. Okay, so that should be pretty simple. And then we just need to implement the touch handler. So touches began, great. So we set this up, and then we do. Gonna pull the first one. Patient in scene view. Again, we do that like solving for the relative position. Test location. We do that. Then we do if let result equals hit results. But first, so if we actually have a hit, we handle touch for result.node, because that is going to be where the raycast is. Great. So then the only other thing we need to do is get rid of our camera control for now. So let's see if this now works. So if we head on over here and make ourselves a new version of this, if I tap an object, they disappear. So our raycasting is working absolutely perfectly, which is great. Lovely. Cool. So that is all working phenomenally well, which is always good. So then let's think about this. Let me see if I can find a particle system for this. What I'm after here is a particle. What I want to do is put together a sort of particle system for explosions. Okay, let's see what we can do here. I want like a nice firework almost. So we'll see if we can find something here. Or if not, we'll just create ourselves a little... Yeah, we'll go from brass tacks on this one. Let's just do it from scratch. Okay. So let's get this sorted. Here we go. Okay, so let's run ourselves up a wonderful little piece of kit. Let me size that a little bit. Okay, so we've got our create trail. We're going to do our create explosion geometry. We're going to set up as usual. We're going to set up as usual. Rotation, we're going to set up there. Okay. So let's see. Let's see what we can do with this one. So what do I have? There we go. Let's try this. We'll see where we go. Explosion dot emitter shape. Location is the surface. Let's set up a rotation matrix. So we're going to want a translation. We need a rotation translation and a transform. We take both of these. And there's the transform. Phenomenal. Okay. So then just before we do the removal here, we're going to do presentation.rotation. It's going to be the same for both of them, which is great. Okay. And then also we'll build ourselves a little something in a minute. I've got an idea for where I want to go with this. One little effect for the road. Okay, so let's bring this back up. And what we are going to do here is run our new version. So if I click one of these now, okay, this may need a little work. Not least because we have 27,000 things that are not despawning anymore, which is a problem. Okay, hold on. Let's amend these slightly. That's fine. That's amended. Okay, let's see if this fixes it. Need like particle geometry. Like randomized. There we go. That's done it. So I think the problem here actually then is that this does needs to be yellow, because otherwise it's not visible against the rest of them. Yeah. Duration 0. We've already set lifespan. I'm just setting up some stuff in the background here to try and fix this particle system. Okay, there we go. Okay, so this is now mostly together. It's interesting that it's only showing up as yellow when it's not on the background. I'm not sure why that's suddenly a thing. Which is interesting. But what I do want to try here, though, is something that just came into my head, which is adding a screen shake just before we head off. So I think okay. Let's see how we go here. Yeah, so let's put an extension down here. Yeah. Oh, that is not what I was after. Extension, SK action. But more specifically, SCN action, because we're now in a new world. Okay. Let's do... motion float, amplitude. Let's see how we go. Break these out as a starting point. I'll do add an actions array because we're going to have multiple. So we're done with this. Okay, so iterate through all of these. It's going to be starting x plus, and we have to do the calculation. Yeah, that's roughly going to be it. Yeah. And it's going to be amplitude y minus CG floats amplitude y divided by 2. Move 2, and it's going to be CG point make. That's our 0.15 interval. It's fine. And then what we're going to have to do is add starting point, and then action.sequence actions array. Yes. Okay, we may have to do some little bit of work here just to whip this into shape, but then I think we should be in a decent place because these are actually going to be... Wait, cannot convert. Oh, because I'm doing this as... Yeah. That should then fix it. Wait, what does this actually mean? Ints. So is that actually gonna, hang on. Okay. So go through and just replace X with Y. Wrap that. Oh shit, yeah, do we even use index? I don't think we do we? No, it's just, I just use it as an swivel, so yep, that can be blanked out. Phenomenal, okay. So then, theoretically, with a little bit of luck, if we pull our wonderful project back in and rerun it, what this should do... Oh no, because we're not calling it, are we? Hang on. What are we doing here? Let's try this. Wonderful. So put those initial argument labels in. Let's see if this now works. So if I click one of these... Okay, that is not doing anything like what I was expecting it to, and I'm pretty sure the reason why... might be because the node's getting deleted. There we go. Oh! What the... That is not the anticipated effect, admittedly. But it's one of them. It's very vigorously moving the particles, but nothing else. Let me try taking the particles out and seeing if that changes this. Because that is very odd. That's interesting. It's not affecting... It's not actually affecting the camera. Which is interesting. But that might be... Oh, wait, hang on. Hang on. I can run it on the camera node. That's what I need to do. That's my mistake. Okay, that is definitely my mistake. But also, what have I done? Because it's not resetting back. It's not resetting itself back to the initial position like it should do, which is very interesting. Okay. That is extremely unusual. I think that is honestly a pretty good place to call it for today. We will take a look at that very fun, very intriguing bug next time, and also take a look at how to add a HUD under SceneKit. So we'll add some score tracking, add a few other nice bits, push a few bits on. Maybe even if we have time, we'll take a look at GameKit as well and add some what's the term I'm looking for? Score tracking with your friends. That is exactly what I was after. Wonderful. All right, well, your folks have a wonderful rest of Global Hack Week. Please do feel free to join me for the next episode of this wonderful little thing, whatever it happens to end up being. And I will see you all when I see you. Happy hacking.